A long straight wire along the z-axis carries a current I in the negative z direction. The magnetic field vector B at a point having the coordinates xy in the z is equal to 0 plane is to be calculated. So let us draw the z is equal to 0 plane, which would look like this. The horizontal axis is the x-axis and the vertical axis is the y-axis. The z-axis is coming out of the plane. Current is going into the plane in the negative z direction. The current has a magnitude I. The magnetic field strength is given by Biot-Savart's law, which tells us that B is equal to mu naught I by 2 pi r, and the direction of the magnetic field is given by the right hand thumb rule, which means if we put our right hand into a thumbs up gesture and point the thumb along the direction of the current, then the curl of the fingers tells us what is the direction of the magnetic field, which in this case would be counterclockwise. Now, if we had some point x, y, then the magnetic field would be along this line, which is perpendicular to the line joining x, y to the origin. Let us say that this slope is m1 and this slope is m2. Product of slopes of perpendicular lines is equal to -1. And we know that the slope of m1 is y by x. Therefore, we have m2 is equal to minus x by y, or in other words, the magnetic field vector is parallel to y I cap minus x j cap. And let us say that B vector is equal to k times y I cap minus x j cap. Let us quickly verify the direction of this vector. If x and y are positive, as they are in this diagram here, y I cap means the vector is pointing towards a positive x direction, and minus x j cap means that the vector is pointing in the negative y direction, both of which agree with the diagram which we have derived from the right hand thumb rule. So we have to find out what is K. So the strength of the magnetic field, or the magnitude, would be equal to K times root over x square plus y square. But from Biot-Savart's law, we already know that it's mu naught I by 2 pi r. So the left hand side is mu naught I divided by 2 pi. What is r here? R would be the square root of x square plus y square, which is the distance between the point and the wire. And this is equal to k root x square plus y square, which means k is equal to mu naught I divided by 2 pi into x square plus y square. And hence we have B vector is equal to mu naught I by 2 pi x square plus y square into y I cap minus x j cap. And this aligns with option A, and hence option A is the answer.